Hello everyone, good evening. I hope all of you are good and I am also good. So today I will take another class from physics, from modern physics. The chapter is nucleus. Okay. So first I write down the formulas of the nucleus, and then we will do some previous year questions from NEET or JEE section. Okay. Fine. So radioactive decay. What is radioactive decay? That is number 1, n equal to n0 e to the power minus lambda t. Okay, this one is radioactive decay law, or dn by dt equal to minus lambda n. Okay, where n0 equal to radioactive sample at time t equal to 0 and n is equal to radioactive sample at time t equal to t. Okay, and lambda is decay constant, sir, and dn is disintegration at time dt. Okay, so this one is radioactive decay law, and which variable is used? n0 is the radioactive decay sample at time t equal to 0 and n is the radioactive sample at time t equal to t, and lambda is decay constant and dn is disintegration at time t equal to at time dt. Okay, now half life. Okay, next heading is half life of a sample. So half life means it is the time at which the sample becomes the half of the previous one. Okay, at which the sample is become half of the previous one. That is t half is what? 0.693 by lambda, or log 2 by lambda. Okay, so this is the relationship between half life and decay constant. There is relation between half life and decay constant. Okay, next one is mean life. Next one is this. There is one formula, n equal to n0 1 by 2 whole to the power n. There is one formula where n is t small t by t half. Okay, small t by t half. There is n is number of half lives. N is number of half lives. Fine. This one is one relation. This 3, there is 4, this one is 3 and this one is 4. Okay, now another one, mean life of a radioactive sample means the average life of all radioactive substances. Okay, so it is denoted by tau. The tau is what, sir? 1 by lambda or t half by 0.693. Okay, or 1.4 into t half. So this is the relationship between what? Half life and mean life. Mean life is denoted by tau and half life is denoted by t half. Half life is denoted by t half. Okay, fine. There is mean life and decay rate or activity rate. This one is 5. That is decay rate or activity rate is what, sir? Decay rate or activity rate is dn by dt, r equal to mod of dn by dt is equal to lambda n is equal to lambda n0 e to the power minus lambda t. This one is known as radioactive decay law. This is formula number 6. Okay, this one is formula number 6, radioactive decay law. So got my point? Fine. The seventh formula is the time required to reduce the radioactive substance, to reduce the radioactive substance. Okay, time required. So T equal to 2.303 by lambda into log n0 by n. Okay, so this is the formula of time required to reduce the radioactive substance. Now decay constant, and its formula is decay constant. Decay constant we can write in this way also. So lambda equal to 2.303 by T into log n0 by n. So this is another relationship. Okay, this is another. This one is time required. There is time and decay constant. Time required to reduce the radioactive substances T equal to 2.303 by lambda log n0 by n, and here is decay constant is lambda equal to 2.303 by T log n0 by n. N0 is initial radioactive substance and n is radioactive substance, where n0 is initial radioactive substance at T equal to 0, and n is radioactive sample, at time T equal to T, and lambda is decay constant and time T is time and lambda is decay constant. Okay, so these are the formulas. From this formula we will do some numericals previous year question. That means it may come NET or IIT JEE. Okay, so move on the questions. So students, our first question is like that. The half-life of radium is 1600 years. So what is given here, sir? So given half-life. So T half is equal to 1600 years. After how many years? 25% of radium block will remain unchanged. So 25%. So N equal to what? 25% of N0. Okay, N will be 25% of N0. So it will be 25 by 100 into N0. So N0 by 4. It will be cut, it will be 4. Okay, so number of half-lives we don't know, and time we also don't know. So we know that there is formula N by N0. Yes, N by N0 equal to 1 by 2 whole to the power N. Okay, so N by N0 is what? N is N0 by 4. So N0 by 4 divided by N0 equal to 1 by 2 whole to the power N. From that we can find number of half-lives is what? N. It will be 1 by 2 whole square and 1 by 2 whole to the power N. So base is same, so power will be equal. So N equal to 2. So this is the number of half-lives. Okay, number of half-lives. Got my point? Now we have to find out the time required, time of disintegration. Therefore time of disintegration equal to, that is T equal to T half into N. This number of half-lives. Number of half-lives is 1600 and N is 2. So 3200 years. So how many time required to reduce this part is 3200 times will be required. So that is option A is the correct answer. Option A is the correct answer. So got my point? So what I am doing here, first I read in the question given that half-life of radium is 1600 years. I write T half equal to 1600 years. Number of after how many years 25% of the radium block is remain unchanged. There is N equal to what? 25% of N0. So that is 25 by 100 into N0. So 25, if I cut this by this, it will be 1 by 4. There is N0 by 4. So N is what we have to find out first. There is number of half-life. After that we have to find out the time. So there is a formula. You know that there is a formula N by N0 half whole to the power N. So N is what, sir? N0 by 4. N0 cut 1 by 4. There is 1 by 2 whole to the whole square equal to 1 by 2 whole to the power N. If we compare this, you will get N equal to 2. Okay, that is the number of half-life. So now time of disintegration is what? T equal to T half into n. So this T half is 1600 and n is 2. So after multiplication it is came 3200. So which option is correct? Option A is the correct answer. Okay. So what is given? A sample of radioactive substance contains 4 into 10 to the power 16. It is 4 into 10 to the power 16. Okay. 4 is 10 to the 16 active nuclei. Okay. So what is given here? Given N0 equal to 4 into 10 to the power 16. Okay. Now half life of the element is 10 days. So T half is 10 days. Then the number of nuclei decayed after 30 days. There is T equal to 30 days. So number of half lives, because number of half lives, that is n equal to is what? N equal to T by T half. Okay. So T by T half. T is 30, T half is 10, so it will be 3. So n equal to 3. Now the number of nuclei decayed is n equal to question mark. So we know that n equal to n0 1 by 2 whole to the power n, is not it? So n0 is what? 4 into 10 to the power 16, 1 by 2 whole to the power 3. So 4 into 10 to the power 16, it will be 1 by 8. If I cut this, it will be 2. So 1 by 2 into 10 to the power 16 nuclei. So it will be 0.5 into 10 to the power 16 nuclei. Okay. So 0.5 into 10 to the 16. Which option is correct? Option A is correct. So how I can do this one? So let me explain shortly how I solve these questions. Okay. In the question, look at the questions. A radioactive sample of substance contains this active nucleus. That is N0 is equal to given. Half life of the element is 10 days. That is T half is given, and the number of decayed nucleus, that is n, we have to find out after 30 days. That is T is total time decay is 30 days. That is T is 30 days. Okay, 10 days, 30 days. So number of half life is T by T half. That is 30 by 10. That is 3. Okay. Now there is a formula. We know that n equal to n0 half whole to the power n. So I put the value of n0 is here. That is half whole to the power 3. Okay. So if I cut this by this, it will be 1 by 2. So 0.5 into 10 to the power 16. That is A. Okay. So move on the next question. This question is came CBSE PMT. Move on the next question. Okay. So our next question, that is question number 3, is two radioactive substance A and B have decay constant 5 lambda and lambda respectively. At time t equal to 0, they have the same number of nuclei. Okay. And the ratio of the nuclei of A to those of B will be 1 by E square. After a time interval is what? Okay. That is, we have to find out the time is what. Here we have to find out time is what. Here n0 equal to n0. Okay, both is equal, and na for the first and nb for the second, and decay constant is lambda 1. Lambda 1 is 5 lambda and lambda 2 is lambda. Okay, so we know that na equal to n0 e to the power minus lambda 1 t, and nb equal to n0 e to the power minus lambda 2 t. So n0 e to the power minus lambda 1 is what? 5 lambda t. It will be n0 e to the power lambda 2 is lambda t. Okay, this one is equation 1, this one is equation 2. So therefore n1 by nb is equal to what? The given na by nb is given 1 by e square. Okay, this one is given 1 by e square. So now if I write this one, it will be n0 e to the power minus 5 lambda t, n0 e to the power minus lambda t. This one is to cancel. So n by na by n0 is what? Na by n0 is 1 by e square. Lambda t plus lambda t, 1 by e square is equal to e to the power minus 4 lambda t. So 1 by e square is equal to 1 by e to the power 4 lambda t. So 1 by e square, so 1 by e square is equal to 1 by e 4 lambda t. 1 by e 4 lambda square is equal to 1 by e whole to the power 4 lambda t. So be base is equal, then power equal, base is same, then power will be equal. So 2 equal to 4 lambda t. So t equal to 2 by 4 lambda, that is 1 by 2. So 1 by 2 lambda. 1 by 2 lambda. So 1 by 2. Which option is correct? Option C is the correct. So this is the answer. Okay. So this is the answer. Now the radioactive substance. So let me explain again in 10 seconds. Okay. So what is given? Two radioactive substance A and B is given, have constant 5 lambda and lambda. So lambda 1 is 5, lambda 2 is 2 lambda. At time t equal to 0, they have the same number of nuclei, that is Na and Nb. 0 will be same number. At time t equal to 0, they have the same. T equal to 0. At t equal to 0, they have same number of nuclei, that is N0. Okay. And Na by Nb, the ratio of nuclei of A and those of B will be what? 1 by e square. That is Na by Nb is 1 by e square. After a time interval, that is t, we have to find out. So I write the equation, that is n equal to n0 e to the minus lambda 1 t. I put lambda 1 value here, and nb equal to n0 e to the minus lambda 2 t. That is I put the value of lambda 2 here. After that I divide equation 2 by equation 1. Sorry, equation 1 by equation 2. I divided equation 1 divided by equation 2. So we get n0 will cancel out, and after that it will be e to the minus 1 lambda. After simplification, what comes? Like that. There is, if base is same, then power will be equal. So from that we can find t equal to 1 by 2 lambda. Okay. Got my point? Okay, sir. So move on the next question. Okay. This question also came in CBSE PMT. CBSE PMT, that is, we can say nowadays NEET exam. This question also came in NEET exam. Okay. In previous days, this is known as CBSE PMT. Now we know that known as NEET. Okay. So students, our next question, that is question number 4, is like that. The half-life of a radioactive isotope X is 20 years. It decays to another element Y, which is stable. Okay. There is half-life of first element is 20 years. Okay. T half of X is equal to 20 years. Okay. And another element is stable. Okay. And if the two elements were found to be in the ratio 1:7, okay, so nx by ny is equal to 1:7. Sorry, 7:1. Nx plus ny is 7:1. So nx plus ny divided by nx is equal to 7 plus 7 by 1, 7 plus 1 by 1, that is 8 by 1. So nx plus n0, nx is n0, that is nx is equal to 8 by 1. Okay. It will be n. Nx is what? N. So we know that there is a formula, n equal to n0 into 1 by 2 whole to the power n. So n by n0 is equal to 1 by 2 whole to the power n. So n by n0 is what? 8. N by n0 is 1 by 8, 1 by 2 whole to the power n. So it will be 1 by 2 whole to the power 3, that is 1 by 2 whole to the power n. So n will be 3. If base is equal, base is same, power will be equal. Okay. Now the age of the rocks, is t equal to t half into number of half lives, and that is t half is 20, that is 3, that is 60 years. The number of rocks is 60 years. So which option is correct, sir? Option B is correct. So option B is the correct answer here. Okay. Got my point? So let me explain again. The half-life of a radioactive isotope is 20 years. It decays to another element which is stable. Okay. So the two elements X and Y found to be in the ratio 1:7. This 1:7 or 7:1. . yes, 1:7. Okay, then in a stable rock, the age of the rocks we have to find out. So t half is 20 years, nx by ny 7:1. So nx plus ny by nx is equal to 7 plus 1 by 1, that is 8 by 1. Okay, so n by n0 is 8 by 1. So there is a formula, that is n by n0 e to the power minus n by n0 into 1 by 2 whole to the power n. So n by n0 is what? 1 by 8. After simplifying, what becomes? N is 3. There is age of the rocks, that is t equal to t half into n. I just put the below t half 20 and n is 3. So after becomes 60 years. So which option is correct, sir? Option B is correct. Okay. So our next question is, and this question is also came in AIPMT, CBSE, PMT. Okay. This NEET in which year? NEET 2015. And this question is came. Okay. If radius of the 13 aluminum 27, this one is atomic number, this one is mass number, nucleus taken to be RL. So radius of the aluminum is RL, then the radius of the thallium is what we have to find out. Okay. So here we know that there is a formula, R proportional to 8 to the power 1 by 3. So this is the relation. This is the relation between radius and atomic mass. Okay. So here R aluminum by R thallium is equal to atomic mass of aluminum is not atomic mass of aluminum by atomic mass of thallium is whole to the power 1 by 3, and it is also whole by 1 by 3. So atomic mass of thallium is what? 125. So 125 whole to the power 1 by 3, and this one is 27 whole to the 1 by 3. If I cut this, it will be 5 to the power 3, 1 by 3, 3 will be cancelled. Here it will 3 to the power 3 whole to 1 by 3, 3 will be cancelled. Okay. So come here. Therefore R aluminum by R thallium is equal to 5 by 3. So R thallium, 5 R thallium equal to 3 R aluminum. So R thallium is equal to 3 by 5 R aluminum. Okay. So which option is correct? Option B is correct. 3 by 5 R aluminum. Okay, is the correct answer. Got my point? This is another formula from the nucleus. Okay, there is radius, and radius is directly proportional to what? Radius is directly proportional to R equal to R0 8 to the power 1 by 3 is the formula. Radius is directly proportional to 1 by 3 power of A. A means atomic mass. Okay. So I just put the value here. A aluminum is what? A aluminum is 27, and A thallium is what? 125. This one is mass number. You know that this one is atomic number, this one is mass number. Okay, this one is mass number, and this is also mass number, and this one is atomic number. Okay, this one is also atomic number. So after simplification, what came? AL by RT equal to 5 by 3. There is a 5 RT equal to 5 RL. So RT equal to 3 by 5 L. Okay, got my point? Fine. So move on the next question. Very nice. Move on the next question. So our next question, that is question number 6. What is the respective number of alpha and beta particles emitted in the following relative to decay? This one is given. Number of alpha particles is what, and number of beta particles is what emitted from this. We have to know this. So here I write one notes for all of you. If a alpha particle is released, then its atomic number decreases by 4 unit and mass number decreases by 2 units. Okay, that is, if one X element is here and this is A and this is Z, okay, and alpha particle is released from that, then it is become Y, it will be A minus 2, and here will be Z, this one is A and this one is Z. Here will be Z minus 2, that is atomic number will be 2, atomic number will be decreased by 2 units and mass number will be 4 units. In case of beta particle, if a beta particle is released, okay, this is known as Soddy-Fajans rule. Soddy-Fajans rule, okay, this is known as Soddy-Fajans rule. You have to remember this one. So if a beta particle is released, then its mass number remains same, but atomic number increases by 1 unit. Increases by 1 unit. Okay. So if a beta particle is released, then its mass number is remains same, but atomic number increases by 1 unit. Okay, got my point? So now come it here. I write it down, and 200. This one is Y 80 168. If gamma particle is released, there is no change. If gamma particle is released, there is no change. So here mass number decreases is equal to 200 minus 168, it will be 32. So number of, since beta particle release, after beta particle release, it is not affected the mass number, so we can date the mass number will be affected only here alpha particles. Okay, so number of alpha particles is equal to 32 by 4, because if the alpha particle is released, then its atomic number is decreases by 4 units and mass number is 2 units, so it will be 8. So number of alpha particle is what, sir? 8. Now we know that now atomic number decreases, what, 90 minus, for 1 alpha particle atomic number decreases by 2 units, so 8 alpha particles decreases, so atomic number will be decreases what, 2 into 6, that is 90 minus 16, that is 74. Okay, but here is what, 8, so number of 80, here is 80, so number of beta particle is 80 minus 74, that is 6, that is 6. So alpha particle will be 8 and beta particle will be 6. So this is the answer, 8 and 6. Option B is the correct answer. So option B is the correct answer. Okay, got my point? Fine. So let me explain again. This one is from Soddy-Fajans rules. That is, if a alpha particle is released from a radioactive sample, then its atomic number is decreases by 4 units and mass number is, atomic number decreases by 2 units and mass number will be 4 units. If a beta particle is released from a radioactive sample, then its mass number will be unaffected. No change will be there in the mass number, but atomic number will changes by increase by 1 units. Okay, fine. If a gamma particle is released from a radioactive sample, there will be no change in atomic number and mass number. It will be no change. Okay, it will remain as it is, mass number and atomic number. Now come it here. Here is atomic number is mass number is initially is 200 and here is finally 168. So mass number will be decreases. How much? 32. And this 32 is for what? For due to alpha particles, because since beta particle releases does not affect the mass number. Okay, so for 1 alpha particle mass number decreases by 4 units. So for 32, for how many particles? So therefore we can say from number of particles, alpha particles is what, 32 by 4, that is 8. Now atomic number total decreases is 90 minus 8 alpha particles, 8 alpha released, so 8 into 2, so total atomic number decreases for 8 alpha particles is 16. So therefore atomic number decreases 90 minus 2 into 6, that is 16, it is 74. But here instead of 74, what is came here? 80, because after beta particle release, atomic number is increases by 1 unit. So number of beta particles will be 80 minus 74, so 6. So option, which option is correct? Option B is the correct answer. So got my point? And this is our last questions. So I hope all of you enjoyed this class. you just focus on this pattern and you just practice more 2 questions from every patterns, okay, and you will be able to answer all the questions in NEET or JEE. Okay, so thank you for watching. If you like this my video, please share with your parents, share with your friends and other students, and subscribe this channel. Okay, so thank you for watching.